पहले बता दो कि कोई स्पेसिफिक पेपर वगैरह कोई चीज करनी है तो वो कर लेते, वरना फिर वैसे एक ओवरऑल सारों की रिवीजन हो रही होगी. जस्ट 1 सेकेंड. अच्छा, यहाँ से इस पेपर को स्टार्ट ही कर लेते हैं. जैसे क्विक वन के ट्रांजिशन मेटल्स, ठीक है, वो थोड़ी थोड़ी रिवीजन करते रहेंगे साथ साथ बीच में. ये मैं देख लूं आवाज. अच्छा, starting with the first question, chromium 3 plus की ना, you have to write the electronic configuration. Periodic table खोल लेता हूँ. Just 1 second. अच्छा, chromium is, I think chromium is 24. So 24, that's 1s2, 2s2, 2p6, 3s2, 3p6. फिर chromium was that special case for 4s1 or 3d5 होता था. And since it's 3 plus, that means this electron and 2 electrons from here are gone. Here, define the term. What is a complex ion? It's an ion that is formed when what happens when a central metal cation datively bonds with ligands. The next one is he's asking what's going to happen samples of CrH2O6 3 plus are reacted separately with either NaOH, H2O2 or excess NH3. Use this information in the data booklet to suggest the formula of the chromium species formed. State the type of reaction that's taking place. तो उससे पहले information दी हुई है कि chromium has similar chemical properties to cobalt. ठीक है, कोबाल्ट का रिमेंबर ligand exchange is part of your course. वो क्विकली एक रिवीजन कर लें उसकी कि क्या क्या ligand exchange कोबाल्ट के थे. कोबाल्ट एंड कॉपर. तो रिमेंबर ligand exchange of cobalt and copper. तो वो यहाँ पे कॉपर और कोबाल्ट के सारा पता होना चाहिए कि कॉपर के अंदर व्हाट हैपेंस इज के you have it's surrounded by water. You add NH3, it gets surrounded by NH3. That's uske color changes. You have to remember that. Concentrated HCl, it forms a tetrahedral complex UCl42 minus. You add NaOH, it forms a precipitate of OH ends. Cobalt had exactly the same. It had exactly the same structure. So the question is about chromium has the same features as cobalt. So with NaOH, what would happen is formula of the chromium species, it will form a precipitate, chromium hydroxide. Copper would form copper hydroxide, cobalt would form cobalt hydroxide. Type of reaction, that's precipitation. NH3 के साथ क्या होता था? Excess NH3, the water molecules would get substituted by ammonia. So this is exactly what's going to happen over here as well. So there's going to be 6 NH3s and it's going to be 3 plus, and this is ligand exchange. Then he's also asking what's going to happen with H2O2. Now you did not do any ligand exchange reactions with H2O2. So यहाँ पे he has said that you use the data booklet as well, so that maybe you're getting a redox reaction in this case. So वो देख लेते हैं what's going to happen. Cobalt and you've got H2O2 over here. तो डेटा बुकलेट पे अच्छा, this will be printed next to your question now. So you've got cobalt or chromium. Now chromium 3 plus is over here. You can remember chromium 3 plus aqueous is actually aqueous state mein, it is going to be forming a complex. So I think we're dealing with this thing, chromium 3 plus. So there's a chromium 3 plus over here as well. And he's asking for a reaction of chromium ions with H2O2. So if you look over here, so there's a reaction of H2O2 over here. And is there another reaction where H2O2 is involved? There's no. There's a reaction over here, like that's acidified. I don't think he's using acid. So you've got this reaction. So with chromium, what's happening is, so what's happening with chromium is, क्या होगा H2O2 के साथ? If you just have a look carefully, chromium is the lower potential. Chromium 3 plus is the lower potential. So it won't be able to gain electrons. It's a negative voltage. So it would probably not be able to gain electrons. Now H2O2, on the other hand, is the higher potential. So it won't be able to lose electrons. You can remember, higher potential gains electrons, does not lose electrons. So that would probably not happen with chromium because chromium is the lower potential. Chromium की सारी equations जो है ना, they are actually your lower potential. कोई और equation तो नहीं H2O2 की? Is there any other equation for H2O2? I mean, there's one. I'll just have a quick look. Is this acidified? They haven't added any acid. So coming back to this, for H2O2, I only have this one. And for chromium 3 plus, I've got these three, but they're the lower potentials. They won't be able to gain electrons. Lower potential does not gain electrons. So apparently there should not be a reaction. I mean, there should be no reaction, no redox reaction. Lekin he's also said that it has similar chemical properties to cobalt. So maybe he's saying, think of chromium as cobalt. So if we think of chromium as cobalt, then we might have a chemical reaction because cobalt 3 plus ko agar dekho na yahan pe, cobalt 3 plus has a very high potential. It's 1.82 volts. So higher potential would gain electrons and lower potential would. This is 0.68. This is the lower potential. It would lose electrons. So if I were to take cobalt, then it would gain electrons. नहीं, लेकिन मसला है कि वो उसमें if I choose the third equation, then it's not chromium that's gaining electrons, it's Cr2O7 that's gaining electrons, ठीक है? So I won't be able to actually use that equation. क्योंकि हमने तो reaction chromium 3 plus का देखना था ना, so we won't be able to do that. अच्छा, problem है कि with chromium 3 plus you're not getting a reaction because you've got a lower potential, they don't gain electrons, ठीक है? So लेकिन he said that it had similar properties to cobalt 3 plus, so cobalt 3 plus would be the one that would be gaining electrons. So if I select that, then there would be reduction happening and your chromium species would turn into chromium 2 plus. So यहाँ पे confusion है, ठीक है? Because chromium 3 plus is not undergoing any reaction, but he says that it's got similar chemical properties to this thing. अच्छा, लेकिन यहाँ पे भी cobalt 2 plus है. One second. The cobalt 2 plus, that's still the lower potential. Cobalt 2 plus will not be able to gain electrons. इसका देख लेते हैं मार्क्स की में H2O2 के साथ उसने क्या दिया हुआ है. Just one second. So sample shows, just one second, let me just go through this once more. Okay, so this is the paper. As he's saying, formula of the chromium species, Cr2O7. I think we are missing one equation somewhere. इसको फिर से गौर से देखो. He's saying that the Cr3 plus gets oxidized, loses electrons. Who loses electrons? The one that has the lower E naught. Or second, it's forming Cr2O7. So H2O2 must have the higher potential. So I think we missed out on one equation. There must be some equation somewhere where there's H2O2. और वो ये वाली लेयर है, एक सेकेंड. H2O2. Do you see H2O2? So I think he's taking this one. The one that has H2O2. That is the higher potential. It gains electrons, and your chromium 3 plus is the lower potential that loses electrons. There was only one problem over here. Our problem is that he did not write that it is acidified, whereas यहाँ पे it's shown that it's H2O2 acidified. तो वो बस एक चीज थी which was not actually given in the question. यहाँ पे question में acidified तो नहीं लिखा हुआ. नहीं, बस H2O2 aqueous लिखा हुआ है. So it should have written acidified, ठीक है? इसलिए मैंने वो equation जो थी वो reject की हुई थी. लेकिन but is this part clear? This one? Okay, H2O2 is the one that's gaining electrons, higher potential, and chromium 3 plus is the one that's losing electrons. That's your lower potential. You clear?
Excuse me, sir.
Haji.
Sir, I have a doubt in that. Like in cobalt, replacing with the OH, does it should be the green PPT or blue PPT in cobalt?
No, it's green precipitate. It's this one.
I mean, like most of the
there was just one market scheme, and that was wrong. Cobalt with OH, that's an insoluble green precipitate. If they write blue, it's not blue. Okay, that's incorrectly written. It's blue is for copper with OH ions. I mean this one. Copper with OH ions, that's an insoluble pale blue precipitate. Okay, clear?
Okay.
Remember, cobalt with OH, that's a green precipitate. So moving on. Explain by the colors of these complexes. He says both are complexes of chromium 2 and have different colors. So why do they have different colors? So different colors, but what do you have to write? Ke pehle to colors ka quickly revise kar lein ke what happens? What happens is that you've got a 3D subshell which is inside the atom. So when these ligands they approach the 3D subshell, some of the 3D orbitals, they face more repulsion. So if the ligands are approaching on the axis in an octahedral complex, then the orbitals which are lying on the axis, they're going to face more repulsion. So aapka jo orbital x square minus y square and your 3D z square, they would go to a higher energy level. Your d subshell will split. And the orbitals that lie between the axes, they're going to face less repulsion. So they're going to go at a lower energy level, the 3dxy, 3dxz, and 3dyz. So there's going to be an energy gap, and your electrons would jump from the lower energy d subshell, and they're going to move to the higher energy d subshell by absorbing a frequency that belongs to the visible spectrum. So pehla part, you're going to get two types of questions. First one, uska answer ye hoga, if they ask you why they're colored. So due to repulsion from lone pairs on ligands in metal complexes, the d subshell splits into two energy levels. Electrons from the lower energy d orbital gains energy and moves to the higher energy d orbital. The energy gap delta E matches frequencies which are part of the visible spectrum. Hence, you see a complementary color. Dusra question. This is the second type of question which you have over here, which is, make sure you know the difference. Okay? The second type of question states can be both are chromium species, but when you change the ligand, the color changes. So why does the color change? So the answer to that is if you change the ligand, a different ligand would exert a different amount of repulsion, which would create a different energy gap as the d subshell splits. And E is equal to HF, a different frequency is absorbed from the visible spectrum. So when your electron moves from the low energy d subshell to the high energy d subshell, so it will absorb a different frequency because of the different amount of repulsion due to different ligands. ठीक है, तो उसका ये वाला part है. So in this case, it's this part that you're going to write. फिर अगला part, water and ethane diodines behave as different types of ligands in this complex. Suggest an explanation for this statement. So what is the different type of ligands? Water over here is behaving as a monodentate ligand. It's only making one dative bond. Meanwhile, ये दूसरा कौन सा था? Water and ethane ethanoate ions, these ones, they are behaving as a bidentate ligand because they're forming two dative bonds. So that's it. Okay, that's the answer to this part. Reduce the coordination number of CR and the geometry around each CR atom in the structure. So coordination number, how many dative bonds is one CR forming? That's 6. So the coordinate bonds is 6. And the geometry, when it forms 6 coordinate bonds, this is an octahedral. This is an octahedral geometry. State the type of bond between the two atoms, between the type of bond between the two atoms in the CR-CR bond. ये बीच वाला. ठीक है, that's क्या type of bond होगा वैसे ये CR-CR का?
Covalent.
ठीक है, and what? ठीक है, why would it be a covalent bond? Because same electronegativity है, ठीक है. I mean, they both have the same electronegativity, so they probably would be sharing electrons. ठीक है, if they had been like totally different, then it would have one would have gained electrons, the other one might have lost electrons, etc. So next one is sigma भी ठीक है, sigma is covalent, right? अच्छा, फिर ये कि next one. There's this complex reacts with aqueous acid to form Cr2 plus aqueous ions. Cr2 plus ions react with O2 under acidic conditions. Cr3 plus ions are formed. Use data booklet to answer the following. Construct an ionic equation for the reaction of Cr2 plus with O2 under acidic conditions. So Cr2 plus O2 under acidic conditions. So बैठ के ना data booklet, ठीक है, again. Cr2 plus और क्या है? O2 under acidic conditions. The first one, okay, I'm going to highlight Cr2 plus. What can happen to Cr2 plus? कहाँ पे Cr2 plus? I think there's either this equation, there's this reaction, यहाँ पे भी Cr2 plus है. So Cr2 plus can gain 2 electrons, might lose 2 electrons. So we're not sure what's going to happen over here. Oxygen, don't know. Where is oxygen? So oxygen under acidic conditions. So the oxygen can have, अब यहाँ पे उसने specifically acid लिखा हुआ था, पिछले part में नहीं लिखा हुआ था. So oxygen under acidic conditions. So this one, we can pick this equation कहीं और है, oxygen under acidic conditions. So I don't think there's any other equation.
So there is 4H plus, O2 plus 4H plus.
हाँ, ऊपर है, yes. Right side पे भी देख लो, if there's oxygen under acidic conditions. I don't think कहीं और है, no. अच्छा, so this is definitely the lower potential. chromium ions, right? The lower potential. What happens to the lower potential? It always loses electrons, right? So I'm gonna pick this one. Okay, if I pick the top one, then it's chromium that loses electrons. We don't have chromium. I'm looking for chromium 2 plus, and it's the lower potential, so it would lose electrons, or oxygen ke upar, okay? That's going to be the higher potential. It would gain electrons. So which one is the higher potential? That's 1.23. Okay, so that's your two reactions. Oxygen acidified, higher potential, gains electrons, and the other one, that's the lower potential hit. So I'm going to write down the two reactions. पहले ये वाला लिख लेते हैं. So यहाँ पे oxygen plus 4H plus 1 plus 4 electrons. So I've got oxygen plus 4H plus 1 plus 4 electrons, and I think it was forming 2H2O. और इसकी value क्या थी? The value for this was 1.23 volts. So 1.23 volts the, and the other one. You get that minus 0.41. Chromium 2 plus turning into chromium 3 plus. So chromium 2 plus backward turning into chromium. And this was minus 0.41 volts. The first thing, you have to make an overall equation. So you would have to balance it. Electrons should be equal. So multiply this by 4. And then add them up. So when you add them up, it's going to be what? Oxygen plus 4H plus 1 plus 4Cr2 plus. Or products make it's going to be 2 water molecules and 4 Cr3 plus. Or kuch hai 4 Cr3 plus plus 4 electrons. You get that set. And you can calculate the E0 cell reduction potential minus oxidation. So it's 1.23 minus 0.41. ये क्या value आई है? So 1.64 volts. As a state, thermal stabilities of group 2 nitrates, what do you write? It increases down the group. Then why does it increase? It increases because ionic radius increases. So polarizing power of the cation decreases. And your whatever nitrate ion becomes more stable. So basically a smaller ion with a +2 charge will distort the nitrate ions. It's going to pull the electrons very strongly, so the nitrate ion would become unstable and it would decompose into NO2 and O2. ये typical question है, ये भी आएगा पेपर में, ये हर पेपर में आता है, ठीक है? So just remember this part. So now the other part is you've got lead 2 nitrate decomposes on heating in a similar manner to group 2 nitrates. Write an equation for the thermal decomposition. So it's going to form lead oxide plus 2NO2 plus half O2. Suggest how the ease of decomposition of lead nitrate would compare to that of barium nitrate. Explain your answer. You may find it useful. So you have to compare which one is going to decompose easily. So ionic radius increases, it becomes more stable. So you're going to open the data booklet. Agar wo data given hoga next to the question, so you'll just look for the data, which is who's bigger? Is it lead or is it barium? So इधर गिवन है ये कि पता नहीं कहीं गिवन था. 1 second, यहाँ पे नहीं है. अच्छा, barium is 0.135 nanometers. And similarly, we're going to look for lead. कितना है lead? अच्छा, ये दिया PV plus 2.120, group 14. So remember, bigger ions, cations would have less polarizing power, so they're going to be more stable. There's going to be lesser distortion for. There's going to be lesser distortion of the nitrate ions. फिर अगला part है ethane diode decomposer and heating to produce barium oxide and a mixture of two different gases. Construct an equation for this. तो क्या होगा? BaC2O4 decomposes to form barium oxide. So two other gases, I think guesswork ही करना है. So what could be these two other gases? तो कितना रह गया हमारे पास? We're left with two carbons and पता नहीं, carbon dioxide, carbon monoxide. Would that complete this? Two carbons and that's 4 oxygens. So I think that's it. ठीक है. Joby, that's the only thing that makes sense at the moment. ठीक है, in this equation. इसको ऐसे check कर लेते हैं. This one, C part 1. ठीक है, carbon dioxide and carbon monoxide, or it's given you another option as well. अगला part. So अगला part है कि there's an impure sample of BaC2O4 of mass 0.5 grams is added to 50 cm3 0.02 mole per dm cube MnO4. A redox reaction takes place and all the BaC2O4 reacts. The resulting solution containing unreacted acidified MnO4 is titrated with Fe2+. The endpoint is reached. Calculate the percentage by mass of. अच्छा, तो हो क्या रहा है? He added BaC2O4 and it reacted with MnO4. And a redox reaction takes place and all the BS. So first thing is this reacts with this. That's the first reaction that's happening. So you have to make an overall equation, make sure that the electrons gain and loss are equal. So multiply this by 5, multiply this by 2, and write the overall reaction. That's the first reaction that's happening at this point. So it's 5C2O4. आज और पास पेपर कर रहा हूँ, अगर कोई प्रॉब्लम्स है वो भी बता दो, ठीक है? अच्छा, प्लस क्या ये 2MnO4 -1 plus 16H plus 1. Products would be 5 into 2, that's 10 carbon dioxides, plus 2 Mn2 plus 8 H2O. So that's the first reaction. Then he says all the C2O4 reacts. So if all the C2O4 reacts, he added MnO4 in excess. So इसका मतलब है after the first reaction is over, so the excess MnO4 -1 is the one that's left. So आपके पास है MnO4 -1 बच गया. The unreacted MnO4 is titrated with Fe2+. So that's the first reaction. ठीक है, let's rub this off. So the second reaction is of MnO4 with Fe2 plus. So इसको multiply by 5 करना पड़ेगा, ठीक है? So we're going to construct the second equation, which is okay, it's MnO4 minus 1 plus 8H plus 1 plus 5 Fe2 plus, or product में क्या है? That's Mn2 plus 4H2O plus Fe3 plus. So that's the whole question, ठीक है? There are two reactions. अच्छा, इस क्वेश्चन के बाद मैं सॉल्व करता हूँ, ठीक है? अच्छा, there two अच्छा, so there are two reactions. So he's saying calculate the percentage by mass of in the impure sample. So starting in reverse order, ठीक है? Fe के moles मुझे कोई बता दे. How many moles of Fe are being used in this second reaction? Concentration times volume करो. What are the moles that you're getting? That's a 6.33 times 10 power minus 5, right? So using ratios 5:1, calculate the amount of MnO4 that's left after the first reaction. So divide by 5 करो तो कितने moles आते हैं? अच्छा, divide by 5 में आ रहे. इसके ये कैलकुलेट करो, मैंने नहीं किया ये. 30.4 into -3. नहीं, सॉरी, ये देख लो, ये कैलकुलेट करके देख लो क्या आ रहा है. 30.4 times 0.05 divided by 1000, तो 0.00152 आ रहा है. (1.552 times 10 power minus 3). So divide this by 1.52 divide this by 5, you'll find the moles of MnO4 that's left at the end of the reaction. So that's 0.00050. कितना आ रहा है? 3.04 into 10 power minus 4. So ये वो moles हैं which are left at the end of the reaction. Find the moles of MnO4 that were added initially. So 50 cm cube of 0.2 mole per dm cube were added. So how many moles were added initially? Excess में it's 0.02 times 50 into 1000 divided by 1000. That's a 1 times 10 to the power minus 3 moles. So these were the moles that were added, and these are the moles that are left. So subtract karo, find out how many moles actually took part in the reaction. So so basically over here 6.96 times 10 to the power minus 4 moles. took part in the reaction, you added 1 times 10 power minus 3 moles. There were 3.04 times 10 power minus 4 moles still left after the first reaction. And then you had दोनों को subtract करो, you'll find the moles that took part in the reaction. और उसके बाद क्या है कि use ratios to find C2O4, that's divide by 2 times 5, ratio use करो 2:5. C2O4 के मोल्स निकाल लो, कितने आ रहे हैं? 1.74 times 10 power minus 3. अच्छा, -3 moles. तो ये आ गया. अब you know के the BaC2O4 will have the same moles, because all your C2O4 is coming from there, right? So it's find the mass, moles multiplied by the MR. So 1.74 times 10 power minus 3 multiplied by the MR of पता नहीं क्या होता है, BA is I think 137. ऊपर दिया हुआ, sorry, MR is already given, that's 225.3. That's the MR is given over here. So कितनी mass है ये? That's 0.392 grams. So you're getting 0.392 grams. और उसने कहा था कि कितना ऐड किया था? He had added 0.5 grams. So you can find the percentage purity that in 200. So what percentage do you get? That's 78 something, right? That's a 78.4%. That's the next one. Barium hydroxide is completely dissociated in aqueous solution. Remember, it's a strong base. Strong base, ठीक है? Strong base का pH कैसा निकालते हैं? A strong base completely ionizes. The BaOH2 is going to, it's not going to be a reversible reaction. It's going to completely ionize. It's going to dissociate into its aqueous ions. So it's going to form barium ions and 2 OH ions. So if this is 0.120 mole per dm cube, so OH ions कितने होंगे? That's going to be double. ठीक है, the OH ions will be double the amount, so it's going to be what, 0.24 mole per decimeter cube. Now, अच्छा, इससे क्या कर सकते हैं? There are two ways of doing this. You can either calculate pOH, which is what, it's minus log of the concentration of OH ions. तो क्या वैल्यू आ रही है हमारे पास pOH की? Log of 0.24. अच्छा, 0.62 आ रही है, ठीक है, 0.62. So that's your pOH, and your pH will be 14 minus this thing. And that's 13.38. तो या तो ये वाली आइडेंटिटी यूज कर लो, which is pH plus pOH is equal to 14. So for bases, you can just calculate pOH and you can just move on and calculate pH from there. या फिर वो the other identity, which is that H+1 concentration times OH ion concentration is what? It's equal to 1 times 10 power minus 14, ठीक है? तो उसमें क्या करना होगा कि पहले OH ion concentration इधर put करो, ठीक है? Then find H+1 and then find the negative log and you'll find the pH. अच्छा, फिर next part is standard electrode potential. It's the potential difference calculated between a standard electrode and a standard hydrogen electrode measured under standard conditions. अच्छा, you're given दिए में कुछ cells दिए में, ठीक है? It's given you some cells. 2 electrochemical cells are set up to compare the standard electrode potential E0 of 3 half cells. The diagrams show the results. So this is the negative lower potential. This is the higher potential. And this is the negative potential, this is the high. Achha, what we can do is हम इनका ना potential estimate कर सकते हैं by looking at them. So this is positive. Which one is this? RU, EN? अच्छा सारे एक जैसे लग रहे हैं. अच्छा with EN, I mean it's this one, the EN one, this one. That's got a higher potential compared to the NH3 potential. मैं कोई अपनी तरफ से ना, I'm just going to give it a value. Let's give it 0.8. So RU, ये वैसे ही मैं दे रहा हूँ ताकि I can keep track of which one is the higher one, which one is the lower one. अच्छा, so RU EN, that's a positive one, 0.8, तो वो फिर lower होगा NH3 वाला. Let's give that 0.4. ठीक है, negative potential. अच्छा, फिर इन दोनों में which one? Water has a higher potential compared to EN. So the water one has a higher potential compared to, so let's give this 1.2. Water का potential जो है ना, that's the one with water ligand has a higher potential when compared to the one with EN. ठीक है, तो मैंने एक रफ order बना दिया. ठीक है, I just gave them hypothetical numbers and एक सेकंड में. अच्छा, ये हमें order पता लग गया. ठीक है, so now he's saying कि figure out the most negative one, so that's A. The least negative one, sorry, A most negative, sorry, the lowest one, वो आपका B है. The least negative one, that means the most positive one, that's A. और फिर बीच वाला, that's C बचा है. ठीक है, C will be the middle one. अच्छा, फिर next part is कि you're being asked कि the ligand EN is a bidentate ligand, you represent this, EN is represented by this. Name the type of isomerism that is shown by EN. If you have 3 ENs, तो याद रखना जब भी आपके पास है, you've got 3 bidentate ligands. Isomerism में क्या होता है कि you've got cis trans and you've got optical, right? So remember this. Cis trans happens in octahedral complexes, happens in square planar complexes. That's when you have cis trans. But when you have bidentate ligands, you have optical isomerism. That is, you've got 3 bidentate ligands, you've got 3 bidentate ligands, so they're going to have mirrored versions of each other. Or you have 2 bidentate, and on 2 sides you've got monodentate ligands. Even then you have optical isomers, mirrored versions. So this question mein, the type of isomerism is going to be optical, and you're being asked to draw it. So usko sketch kar lo, you can draw it like this, okay, x or y axis, and then there's this z axis. So n is represented by, En is represented by this thing. So n and connected at the top. अब इसका mirrored version draw करना. So you're going to draw a mirrored version of the same thing, which is axis को भी mirror it. So the dotted is over here and the wedge-shaped one is coming out of the page. And draw your EN around it. Okay, so the EN is also mirrored. So it's on the left side now. This EN is on the left side as well, or this one is on the. So this is optical. So remember complexes So remember complexes. Okay, complexes के अंदर ना it's optical isomerism would only happen if you have 3 bidentate ligands, or you have 2 bidentate ligands, and on 2 sides together you've got monodentate ligands. अच्छा और क्या है? An electrochemical cell consists of a Br2 Br-1 half cell and an Ag+1 Ag half cell. Use the data booklet to calculate the E0 cell, reduce the direction of electron flow in the wire through the voltmeter between these 2 half cells. So आपके पास open the data booklet, you've got कहाँ गया? अच्छा bromine. अच्छा you got a bromine one. So where's the bromine one? That's this one. और फिर एक silver वाला, ठीक है, silver is right next to it. These 2 electrodes. This is the higher potential, it's going to gain electrons. So it's going to go forward. And that is your lower potential, it is going to lose electrons. It's going to lose electrons. So electrons would flow from which electrode? The potential difference, electrons would flow. The lower is going to lose electrons, and the higher one is the one that's going to gain electrons. ठीक है? तो किधर से किधर जा रहा है? It's going from silver to the bromine electrode. तो यहाँ पे लिखना है कि it flows from the silver electrode to the bromine electrode. और इसका potential difference क्या है? Potential difference उसका calculate कर लो. It's higher potential, reduction potential minus oxidation potential, 1.07 minus 0.8. तो 0.27 आएगा. ठीक है? अच्छा फिर अगला पार्ट. Water is added to Ag+1 Ag half cell. Suggest the effect of this addition on the E cell. Place a tick. तो पहले तो water add किया, ठीक है? So water is being added to this electrode. तो ये तो solid है, इसको तो कुछ नहीं होगा. If you add water, the concentration decreases. So the concentration of the ions will decrease on the left side if you add water to it. So if you are adding water to it, where will the equilibrium shift? The equilibrium would shift backwards. Or whenever Lee-Chatterley principle, according to Lee-Chatterley principle, if the equilibrium of an electrode shifts backwards, it produces more electrons. Your potential of that particular electrode would decrease. So your E decreases. So what was the E previously? पहले इसका जो potential था ना, the standard potential, that was 0.80 volts. अब ये वो है कि ये decrease हो गया. कोई value दे देता हूं अपनी तरफ से, let's say it becomes 0.70 volts. ठीक है? So remember, diluting the solution, the equilibrium will shift backwards. नहीं, लेकिन question उसके ऊपर है. It's not about the electrode potential, it is about the E cell. तो आपने जो आंसर करना है ना, this is 0.8, this is 1.07. But now if you add water to it, so it's not going to be 0.8, it's going to be something less than that. वही जो अपनी तरफ से, let's say 0.70. What happens to the potential difference of the E cell now? 1.07, 0.7, so the difference has increased. ठीक है? So E cell actually increases, क्योंकि एक इलेक्ट्रोड आपका 1.07 था और एक जो था that was 0.80. But the problem is that you diluted it, so its potential decreased, but the difference is now actually higher. E cell जो है ना, that's actually higher now. तो इसका आंसर क्या करोगे? बस ये करोगे कि the equilibrium shifts backwards as the concentration of silver ion decreases, and because of that, your E0 cell increases. Not नहीं डालना, because it's no longer under standard conditions. ये clear है ये बात? और इसमें ना ख्याल रखना कि sometimes ना they ask you about E0. People miss these things. ठीक है, the minor things. Sometimes they ask about E0. So E0 तो obviously decrease कर रही थी. But sometimes they're going to ask you about E cell. ठीक है, so the E0 might be decreasing, but the E cell might not be decreasing. It might be increasing. As I define the term ligand, so it's a species which can donate or form dative bonds with a metal ion. Write an expression for Kc for equilibrium number 1. ये वाला. So इसका Kc क्या होगा? It's product concentration divided by reactant concentration. So it's Ag. Product is Ag S2O3 squared. और इसका चार्ज जो है, अच्छा रिमेंबर इसके अंदर चार्ज अंदर लिखना है, ठीक है, because the square brackets represent concentration. The other product is Br minus 1, its concentration divided by your reactants, which in this case will just be S2O3. उसकी concentration will be squared. Solids are not written in the expression. So that's your Kc expression. Some additional data given about the dissolution of AgBr in S2O3. So the solubility product is given, the stability constant is given. Use your answer and these data to calculate Kc for equilibrium number 1. तो उससे क्या इन दोनों को use करके ना find out what Kc is. Okay, इसको use करके you have to find out this thing. So basically you have to somehow come up with this expression and find the answer to this. So how would you do this? First thing, ये KSP का expression क्या होता है? What is KSP? KSP is when AgBr dissolves. So AgBr is a solid. It dissolves, so it forms Ag plus 1, Br minus 1 aqueous, right? So इसका KSP का expression होता क्या? It's silver ion concentration times Br minus 1 concentration, right? So we know the value of this thing. What is this other thing? Stability constant. What is stability constant? It's stability constant is when ligand exchange happens. So this is ligand constant S2O3 2 minus. So when aqueous ions undergo ligand exchange, okay, so it's 2S2O3, and it ends up forming a complex which is what? Ag S2O3. कितने ये दो हैं? Bracket, and it's got a 3 minus charge. As it's got a 3 minus charge, so बस ठीक है, ये ligand exchange. So it's when a metal complex is formed, when a ligand exchange happens, और आपका जो aqueous ion है, it undergoes ligand exchange. अच्छा, अब ये कि what do you do next? अच्छा, what is stability constant expression? Stability constant expression is it's the equilibrium constant for a ligand exchange reaction when a complex ion is in equilibrium with its aqueous ions. So AgS2O3 square and 3 minus concentration divided by the reactant, which is Ag plus 1 aqueous, its concentration, and S2O3 2 minus squared. So we've got these two expressions. A KSP expression and a K-stab expression. So how do you come up with this expression using these two? So that's simple. I think that's you just multiply the two. If you multiply the two, so आपका जो Ag plus 1 है ना, that I guess gets cancelled out, and you're exactly left with the same expression. नहीं divide होगा या multiply होगा? भैया ये check कर लो, is it division or multiplication? Simple multiplication. So बस इसका मतलब है you just multiply the two values. So it's 5.4. So the answer to this is 5.4 times 10 power minus 13 multiplied by 2.9 times 10 power 13. 10 power 13 automatically gets cancelled out. And you're left with 15.6s. So that's your answer to this. So next part. Case tab. The numerical value for the stability constant. Remember stability constant. What is stability constant? It's the equilibrium constant when a complex ion is in equilibrium with its aqueous ions. If K stab has a bigger value, that means the complex ion will be formed and is more stable. And ligand exchange will happen. If K stab has a smaller value, that means the product is not going to be formed. So यहाँ पे वो कह रहे हैं aqueous solution containing Ag+1 is added to a solution containing equal concentration of Cn-1, NH3 and S2O3. So you know the K-stab values for all three of them. So the mixer is left to reach equilibrium. Deduce the relative. अच्छा बताओ कि इनमें से which one has the greatest chances of getting formed out of all these three? आपका K-stab, if it's a bigger value, you got a higher chance of forming it. तो 5.3 ठीक है, AgCN2 -1 ठीक है, that's got the highest probability of getting formed. The second highest probability is for this one. It's got a high value as well, but not as high. So ligand exchange would happen, but the concentration would not be that high. Ag S2O3 twice. Iska charge kya, that's 3 minus. And the last one is AgNH3 twice plus. Or explanation में वही देना है, you just have to write that it's got a higher K-stab value, so it's more stable and more likely to be formed. So lattice energy. What is lattice energy? It's the energy released when 1 mole of ionic lattice is formed from its constituent gaseous ions. Use the data to calculate a value for the enthalpy change of solution of copper chloride. You might find it helpful. So ये solution की Hess cycle. What is solution that a solid 1 mole solid dissolves and dissociates into aqueous ions? That's what enthalpy of solution is. This is what you're looking for. Enthalpy change of solution has two steps. You break the lattice first. So you CuCl2 का जो lattice है ना, you're going to break it. And you're going to turn it into gaseous ions. You're going to turn it into Cu2 plus gaseous plus 2Cl minus 1 gaseous ions. So you're going to break the lattice. So what is the energy that is required to break lattice energy? That's 2824. Or endothermic positive होगी, ठीक है, because you're not forming a lattice, you're actually breaking it. And then the gaseous ions, they turn into aqueous ions. That's enthalpy change of hydration. So the enthalpy change of hydration of Cu2 plus is minus 2099. Or Cl ions की क्या है? That's minus 378 times 2. So cycle बन गई है. So one path is equal to the other path. So you just have to find what are you going to get this. So क्या value आ रही है इसकी? It's plus 2824 minus 2099 minus 378 times 2. इससे पहले क्वेश्चंस भी करने थे. Just 1 second. ये क्वेश्चन इसी के अंदर चैट के अंदर पोस्ट किए हुए हैं. Just a second. Let me try and अच्छा ये क्वेश्चन, just a second. ठीक है, here's the question. ये question था ना. The question states chloride can be identified using aqueous silver nitrate and so 0.303 grams of sulfur is completely hydrolyzed in water. So all the इसमें इस पूरा question दे दो paper. Which paper number is this? चलो ठीक है, इसको कर लेते हैं chloride of sulfur. I think that information is not given. ठीक है. So we have no idea what the chloride of sulfur is. So जो भी हुआ है, it's completely hydrolyzed in water, so it just turns into Cl ions, right? So all the chloride atoms present in the chloride of sulfur are converted into chloride ions. The solution is diluted to 100 cm cube. So he turns it into a 100 cm cube solution, but then he just takes 25 cm cube of this solution. So he's just using 25 cm cube of this solution and is titrated with silver nitrate. So silver nitrate ke saath it's, I think it's 1:1. So he adds 0.05 mole per dm cube of silver ions. And the volume is 22.40 cm cube. इसके मोल्स बताओ कितना सिल्वर आयंस है? नहीं, 1 किस तरह आ रहा है? सिल्वर आयंस के मोल्स 0.05 into 22.4 divided by 1000. (1.12 times 10 power minus 3, right? So the Cl ions will have exactly the same moles, right? 1.12 times 10 power minus 3 moles. लेकिन यहाँ पे जो Cl ions होंगे, that's going to be 4 times more because you just did it for 25 cm cube. So इसको times 4 करो तो you'll find the moles of Cl ions. क्योंकि this is in 25 cm cube. What's times 4? That's 4.12 into 4 क्या होता है? That's 48. ठीक है. So is this clear that Cl ions is 4.48 times 10 power minus 3 moles? अच्छा, now the question is, how do you find empirical formula using this? How do you find the empirical formula of this thing? So you can find the mass of Cl. 35.5 से multiply करो, Mr से Ar से, you'll find the mass of Cl. What is the mass of Cl? So let's say 0.16 grams. So that means, so now it's an empirical formula question. SXCLY, you don't know what the formula is, but you know that Cl is 0.16 grams. Achha, or total chloride ki mass be given at the top, right? He's given you the total mass of the chloride. It's 0.303. So जरा उसको subtract करो ना out of subtract 0.303, subtract minus 0.16 out of it. अच्छा, 0.143, right? इसको मैं 159 कर देता हूँ, 0.159 grams. So now it's an empirical formula question. How do you find empirical formula? Divide by the AR, divide by the AR over here. Sulfur kitna hota hai? That's 32.1. What do you get? इसका है 4.48 times 10 power minus 3. CL का तो नहीं, CL was 4.48. कि दोनों का आ रहा है. And 4.478 is also kind of the same. So isn't it 1:1? So Javier, you clear your question? It was a moles question that ended up turning into an empirical formula question. तो खैर मैं ये पेपर कंप्लीट कर लूं, उसके ग्रुप में भेज देना, मैं वहां पे आंसर कर दूंगा, ठीक है? केपीसी पता नहीं, इसका ना शायद केपीसी हो. तो मैं वैसे भेज दूंगा, ये मुझे उस पर ग्रुप में पोस्ट कर दो, ठीक है? अच्छा, ये पार्ट in the enthalpy change of hydration of calcium ion is minus 1579. Suggests why there's a big difference in the values of delta H hydration of calcium ions and copper ions. Copper ion की क्या है? Copper ion is minus 20. Copper ion is way more exothermic. So copper ion की जो hydration है, that's more exothermic. And calcium ions, that's less exothermic. Hydration होता क्या? Hydration is bond formation. Whenever something gets hydrated, तो hydration क्या होता है? Hydration is a gaseous ion forming bonds with water molecules. तो जो छोटा ion है ना, smaller ions, the smaller ions have greater charge density and make stronger bonds. And they make stronger bonds, which is why copper ions are smaller. ठीक है? They are smaller in size. Data booklets, you're going to quote the values that they are smaller in size. अगर transition metals पता है, तो transition metals are, remember, always smaller in size. So which is why that's more exothermic. Identify the substance formed at the anode and cathode during the electrolysis of calcium. Saturated calcium. Saturated is concentrated. ठीक है? Now there's two ways of doing this. You can either go through the whole data booklet and do the electrochemistry thing. Yeah, simple O-levels. Simple O-levels में क्या था? You've got, जब भी saturated होगा ना, it's always chlorine at the anode. And there's going to be H+1, so there's going to be hydrogen gas formed at the, ये सारे ions होंगे आपके पास, calcium ions, H+1, Cl ions and OH ions in water. Hydrogen gas is going to be formed and chlorine would be formed at the anode.
So
Calcium,
whenever there is attached halogenoalkanes, then we can write that Cl2 or Br2 getting attached to the anode.
हाँ, लेकिन Cl is only if it's concentrated.
Only if it is concentrated.
हाँ, मतलब for example, you can use the data booklet as well to check this. So at anode, at anode, right?
Yes.
So if it's Cl minus one, right? So Cl minus one, you can use the data booklet as well. Okay? For example, this is how you're going to use the data booklet. Okay. What happens at anode? Anode is the positive side. Oxidation happens at the anode. So if it's Cl minus one concentrated or aqueous, so there's water and Cl minus one. So somebody would lose electrons. This is the equation of Cl minus one losing electrons, turning into Cl2. That's 1.36 volts. You've got water as well. It's aqueous, right? So water losing electrons. Do you find an equation for water losing electrons? I think it's over here. We've got two equations where water is also losing electrons. एक second now. So I've got an equation of water losing electrons. So I've got 1.23, 1.77, and I've got 1.36. Now, who loses electrons? Who likes to lose electrons? The one that has the lowest potential. The inside of lowest potential it's the water equation, the one that's forming oxygen. The normal case mein, it's always oxygen gas that is getting formed at the anode. But if Cl minus one is concentrated हमने क्या discuss किया था? Where will the equilibrium shift? It's going to shift backwards and the potential would become lower. So let's say it becomes 1.10 volts. So then it's Cl minus one, that's the lower potential, and that's the one that's going to lose electrons. Okay? So is this part clear that concentrated के अंदर, why is it Cl minus one that's losing electrons? Because in concentrated solutions, this equilibrium lies to the left, which is why the potential is actually going to be lesser. Okay? So तीनों में ना, the one that has the lowest potential is the one at the top, the one with Cl minus one. So it's got the greatest tendency to actually lose electrons. ये बात clear है?
Okay, sir.
और वो दूसरी साइड पे ना gain करना है. Who's going to gain electrons? You have calcium ions and you've got water, right? So where's calcium ions? Calcium ions are over here. Calcium ions can gain electrons, right? And water is somewhere over here as well. Water can gain electrons. So who's going to gain electrons? The battery is giving electrons. Who's going to gain electrons? Calcium ions or water? So the one that has the higher potential is the one that's going to gain electrons, which in this case is the water equation. That's got the higher potential. So क्या बनेगा? Hydrogen gas is going to get formed. ठीक है? तो but anyways, इस तरह के but anyways, छोटे questions होंगे ना, like this one. You don't really हाँ. O levels where you had a reactivity series, and the one that was the least reactive was the one that gained electrons. Because it was just a 1 mark question. So वो वाला काम भी कर सकते हो. If it had been a detailed question, you could have done that way. Now, calcium can be produced by electrolysis of molten CaCl2. Calculate the mass of Ca formed when a current of 0.75 amperes is passed. So Q is equal to IT. Okay, you've got ये मुझे बता दो क्या value. Its current is 0.75 amperes times 60 minutes times 60 seconds. So how many coulombs is this? 2,664 coulombs, right? Now, if it's 2,664 coulombs, you can use Faraday constant to figure out the number of moles of electrons. Because 1 mole of electrons has this much charge. So 2,664 coulombs will have how many moles of electrons? So what is 2,664 divided by 96,500? 0.026 moles. अच्छा, moles of electrons आ गए, निकालना क्या था? Calculate the mass of Ca formed. So Ca2 plus 2 electrons. Ca, so you have the moles of electrons, 0.0276. So moles of Ca would be half of that. It's 0.0276. According to the ratio, it's going to be divided by 2. Divided by 2 होगा ना, 2:1. और फिर ये करना है कि इसको find the mass. So multiply this by the AR of calcium, which is 40.1. तो क्या बना इसका? ऐसा कितना है? 0.55. ठीक है, वो mass आ गया. Explain what is meant by the entropy of a system. It's a measure of disorder of a system. Place one tick in each of the table to show the sign of NaCl dissolving is obviously entropy increasing. Water solidifying to ice, that's entropy becoming negative. फिर वो कह रहा है the evaporation of 1 mole of water has a standard Gibbs free energy of delta G of 8.6 at 25. Delta G positive होता है, that means it's not going to happen. It's the evaporation of water is not feasible at 25. When does the evaporation of water become feasible? It becomes feasible at 100. 100 से आगे जितना भी टेम्परेचर होगा ना, उसके ऊपर the evaporation of water is going to become, it's going to become feasible. तो 100 से आगे, तो 100 से आगे क्या होगा? It's going to become negative. तो स्टार्ट कहाँ पे होनी है? वो 25 के ऊपर it's 8.6. तो लेकिन positive 8.6. But then after 100 it's going to become more and more feasible. तो straight line होगी of if you plot delta G versus temperature. और फिर ये the reaction between A and B is feasible at low temperature but is not feasible at high temperatures. So you have to figure out delta H and delta S sign. So delta G is equal to delta H minus T delta S. Now he's saying, so now he's saying that delta G is equal to delta H minus T delta S. तो यहाँ पे क्या होगा कि it's feasible at low temperatures. So that means at low temperatures, delta G happens to be negative. So low temperatures, let's say I take temperature as 0. तो 0 होगा तो इसका मतलब ये पार्ट तो निकल गया. So how is delta G coming out to be negative? It can only come out to be negative as if delta H is negative. क्योंकि उससे कहा है कि at low temperatures it is feasible. At low temperatures delta G has to be negative. So if I take temperature to be very low, like T is equal to 0, how is delta G coming out to be negative? Because delta H must be negative. ठीक है, एक सेकंड में देखता हूँ उसको. तो अब ये कि this one, then it becomes unfeasible at a higher temperature. So that means this part over here has a positive value. And as the temperature increases, it becomes a larger positive value. How can it have a positive value? Delta S must be negative as well. क्योंकि तभी दोनों चीजें मिलके, so that means both of them are actually negative. Only then would it make sense that at low temperatures, when this thing becomes very small, delta G comes out to be negative. And when at high temperatures, this thing becomes positive. and becomes a large positive value, so delta G becomes positive and the reaction becomes not feasible. ठीक है? तो जो वाला क्वेश्चन मैं कर रहा हूँ, एक सेकेंड. अच्छा, page 55, just 1 second. Page 55, right?
Yeah.
अच्छा, इसमें कहाँ पे कि
It's the
So-
second last page.
this one.
Yes.
अच्छा, so partition coefficient के ratio of the solubility of a solute in two different immiscible liquids. Ammonia is soluble in both water and organic solvents. So an aqueous solution of ammonia is shaken with immiscible organic solvent trichloromethane. So an aqueous layer, right? So इसका मतलब है एक layer जो है ना, that's water, and the other one is trichloromethane, ठीक है, which is क्या trichloromethane का formula क्या था? CHCl3.
Yes.
और ये water है. Now ammonia is your solute, right? It's so there's going to be some ammonia. Because of water में ज़्यादा होगा, and less ammonia in the trichloromethane layer. So a 25 cm³ sample of trichloromethane layer requires so what he's doing is he sets this up. बन गया जब उसके पास, so what he did was he then does titration. अब ammonia जो है ना, that's over here, and ammonia is also in the other layer as well. वो बैठा ना, he's doing titration. What are the moles of ammonia and HCl react in 1:1? So what are the moles of HCl? ये 13 into 0.1 क्या होगा? 1.3 times 10 power minus 3 moles, right? यही होगा ना? So that means ammonia would be exactly the same. So ammonia की concentration निकालो. What is the concentration of ammonia in the trichloromethane layer? Okay, 25 cm³ sample has this much ammonia, right? So find the concentration. Concentration will be 1.3 times 10 power minus 3. But in how much cm³ and 25 cm³? So that's 0.025 dm³. तो इस तरह आंसर बताओ क्या आ रहा है इसका?
$0.052.
कितना?
0.052.
mole per dm³, right?
Yeah, it's in dm³.
So ठीक है, you find the concentration of ammonia in the trichloromethane layer, ठीक है? और फिर 10 cm³ portion ये इसका water layer का aqueous layer, and what are the moles of HCl? That's what, 1.25
into 10 power minus 3. Yes.
और लेकिन वो 10 cm³ में, so what is the concentration? That's divided by 0.01 dm³.
$0.125.
So now calculate the partition coefficient. तो वो क्या होगा KPC? It's the solubility. Solubility could be in gram per cm³, but it could also be in concentration. It's the same thing. So trichloromethane layer, that's 0.052 divided by the aqueous layer, which is 0.125. So what do you get?
0.416.
ये था आंसर, कुछ और था.
Yeah, it was this. So first we found the moles that it took of ammonia. And
हाँ,
then
he took a sample. He didn't take the whole layer. He took a sample, a 25 scene cube sample of the top layer, right? And he titrated it, found the moles of HCl, which were the same as the moles of ammonia. क्योंकि 1:1 है ना. तो आपको अमोनिया के मोल्स पता लग गए, ठीक है?
And then concentration उस volume से निकाल दी. Okay.
हाँ, क्योंकि वो 25 scene cube है ना, so that's the concentration of. So you found the concentration, right? और
Yeah.
so KPC. बस दूसरे नीचे भी पे वही किया आपने. You repeated it and you got the result, ठीक है? Clear?
All right. Yes, understood.
So it's like I think there were a few more questions. So paper 5 में कुछ था कहते कि they would do titration, they would do a reaction and find the concentration indirectly, ठीक है? So और कोई question है?
No, I don't have any right now.
चलो एक सेकंड. अच्छा मैं थोड़ी देर में फिर कंटिन्यू करूंगा, ठीक है? मैं मैसेज कर दूंगा if I'm ending this right now.
Okay. All right.
चलो, okay, Allah Hafiz.
Allah Hafiz.